We have about 2 minutes and 50 seconds until this gets started, so let's go ahead and look at the leaderboard like we normally do. Personal stats. Last night we did 1700th and 1018. We could have done much better on part 1. The fact that we did this well on part 2 actually we're pretty pleased with, though. And if we go to the private leaderboards, we're in first by about 19 points, so yeah, 2 other players here, and then some people are starting to fall off, but I'm sure they'll catch up. Today is Saturday after all, so sometimes people aren't always available. But we're starting to cement our lead here. This is what happens when you show up every night at the time rather than doing it the day after. Which, you know, I understand that some of my colleagues here that are in other parts of the country or the world don't necessarily have the opportunity to start. Oh, and we're 1 point from perfection on the other leaderboard, though I don't think anyone's going to be coming to catch us. I need to ping Ryan and heckle him about that. Let's go ahead and close all the other tabs we have open here. There we go. Wonderful. Let's go ahead and take the headphones off for just a second while we wait. Let's go back to the main thing so we can see. Still have a minute 45. Oof. Take a little sip here. And turn on our light. That's right. That's what we need to do. Oh, there we go. Much better. We can see our face now. Now look over here, because that's where chat is for me. Now, there's nobody in chat. YouTube viewers wouldn't know that. They would think that just a jillion people are watching me right now. But in reality, yeah, nobody here right now. But we could probably afford to do a little bit of this. And I think, yeah, if we look at the problems here, yeah, the problem is we need to zoom just a little bit. Oh, no. Did we just freeze our editor? Oh, no, we're fine. Oh, gosh. That always, whenever you try and zoom on the editor, there's a chance that it's just going to break. But it looks, well, there we go. Is that maybe more visible? Probably. Yeah. That's nice and readable on both sides, which is great. This is going to be a little bit, hogged for vertical space there, but that's all right. Oh, and let's fix our hair during the remaining little second that we have here, 35 seconds. Oh yeah, would you look at that? Easy. Whew. Yeah, check who's in chat. No one that we recognize, which is a little bit of a shame, but somebody will come along at some point, I'm certain. Got about 10 seconds now. It's time to calm down and focus up a little bit. I had a lot of caffeine today and not a lot of food, so I'm a little jittery. But that's all right. We do need to get a handle on what our days have looked like, though. There we go, problem 11. Day 11, monkey in the middle. As you finally start making your way upriver, you realize your pack is much lighter than you remember. Just then, one of the items from your pack goes flying overhead. Monkeys are playing keep away with your missing things. To get your stuff back, you'll need to be able to predict where the monkeys will throw your items. After some careful observation, you realize the monkeys operate based on how worried you are about each item. Here you take some notes, your puzzle input, on the items each monkey currently has, and how worried you are about those items, and how the monkey makes its decisions based on your worry level. For example, Monkey 0, starting item 7998, operation new equals old times 19, test divisible by 23, if true throw to monkey 2, if false throw to monkey 3, etc, etc. Each monkey has several attributes. Starting items list your worry level for each item the monkey is currently holding and in the order they will be inspected. Operation shows how your worry level changes as that monkey inspects an item. An operation is like a new equals old times 5, means your worry level after the monkey inspected the item is 5 times whatever your worry level was before inspection. Test shows how the monkey uses your worry level to determine where to throw an item next. The if true shows what happens if an item with an item if the test was true. If false shows what will happen if the item was false. After each monkey inspects an item, but before it tests your worry level, your relief that the monkey's inspection didn't damage the item causes your worry level to be divided by 3 and rounded down to the next integer. Okay. The monkey takes turns inspecting and throwing items. On a single monkey's turn, it inspects and throws all of the items it is holding one at a time and in the order listed. Monkey 0 goes first, then monkey 1, and so on until each monkey has had one turn. Then the process of each monkey taking a single turn is called a round. When a monkey throws an item to another monkey, the item goes on the end of the recipient monkey's list. A monkey that starts a round with no items could end up inspecting and throwing many items by the time its turn comes around. If a monkey is holding no items at the start of its turn ends. For example, the first round above proceeds as follows. Inspects the item with worry level 79. It's multiplied by 19 to 1501. Monkey gets bored with the item. The worry level is divided by 3 to 500. The current worry level is not divisible by 23. Goes to monkey 3. inspects 98. It's multiplied, then it gets bored, divided by 3. Current wear level is not divisible by 23, goes to monkey 3. Monkey 1 inspects an item of this. Wear level gets increased by this, and that's because monkey 1 has old +6. Okay. Etc. 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 Yeah. So then monkey 3, etc. After round 1, the monkeys are holding items with these worry levels. Monkeys 2 and 3 aren't holding any items at the end of the round. They both inspected items during the round and threw them all before the round ended. This process continues for a few more rounds. After round 2, the monkeys are holding items with these worry levels. After round 3, the monkeys are holding items with these worry levels. After round 4, with these. After round 5, with these. After 6, after 7, after 8, after 9, after 10. After round 15, this. After round 20, this. Chasing all the monkeys at once is impossible. You're going to have to get focused on the 2 most active monkeys if you want any hope of getting your stuff back. Count the total number of times each monkey inspects items over 20 rounds. Monkey 0 inspected items 101 times. 95, 7, 105. In this example, the 2 most active monkeys inspected items 101 and 105. The level of monkey business in this situation can be found by multiplying these together, 10, 605. Figure out which monkeys to chase by counting how many items they inspect over 20 rounds. What is the level of monkey business after 20 rounds of stuff slinging simian shenanigans? Okay, we got the puzzle input, and it looks like it's 7 monkeys. Okay, so first we want a list, and we want a private static class monkey. So there's a monkey, and so far it doesn't have anything, and it needs a needs like a list of stuff, and it doesn't actually matter. Yeah, so list item. It's actually just like a list of integers. List integer items. Would this be better as a deck? Let's see, Java deck. There we go. This has add first, offer first, add last, offer last. Yeah, that's probably better. So instead of a list, we want a deck. Thank you. Items. So items equals new deck integer. Oh crap, what are implementations of deck? Array deck is fine. Array deck, wonderful. Okay, and we should, okay, let's just control Z until all this stuff goes away. There we go. Array deck, there we go. And then we want like we need like some notion of like what its operation is. So basically we want, maybe we just want to pass all these and we can parse it in, because it's going to have like some new function. Is it better to just hard code these? Because there's only 7 of them. That does seem probably better. An interface operation. Int do operation int old. So then we want a monkey with an operation this dot operation equals operation and operation. Wonderful. So now we can just instantiate these directly. Oh yeah, you guys can't see what's going on. So now we can instantiate these just directly because there's only 7 of them. And we probably also want a interface condition. Oh yeah, okay, great. We got somebody wasting our stuff. And this has Boolean passes test. input. Or like into value if we want. Cool. And then monkey, true monkey, monkey, false monkey. Wonderful. So let's go ahead and then we have monkey, true monkey, monkey, false monkey. So then for each monkey we want void. Let's go ahead and assign these. This dot true monkey equals true monkey. This dot false monkey equals false monkey. And I know again you guys can't see what's going on. That's okay. We will get this up there. Okay, cool. So now we want void process each item. Oh, we probably can't set. Well, yeah, we can't have these as okay. So we actually need void set true monkey, monkey, monkey. This dot true monkey equals monkey. Now I want this set same thing, but I want it for false monkey. False monkey. False monkey. Wonderful. Process each item for integer item in items. And so if we go back and look, then the war level gets increased by running the operation, and then it gets divided by 3. Item equals operation dot do operation item. Then item equals item. In fact, we could just divide by 3. And then if oh, so this doesn't take in true monkey and false monkey anymore. We can go ahead and get rid of that, but it does need to take in a condition. Condition. This dot condition equals condition. Wonderful, and we have condition. So if condition dot passes test item, and then we also need a thing which is void receive item integer item. Items dot add last item. Wonderful. And then we probably also want a process each item, and we probably want this return an int so that we can keep track of how many there were. Or though we can also just have, let's do void, and then let's go int inspection count. We can have inspection count equals 0, else this inspection count plus plus. So if condition passes test, true monkey dot receive item, else false monkey dot receive item. And I want to actually reset this from receive item to give item, because we're going to give the monkey the item. Wonderful. So now what we can do is we can have a list monkey list equals new array list. Wonderful. We know this is going to be 7. Monkey 0 equals new monkey. New operation. Do operation. What is the operation that this one does? Old times 5. Return old times 5. New condition. And this is return value percent to equal 0. Does that seem right? That does seem right. Monkey lists dot add monkey 0. Cool. So we basically want to do this over and over again. In fact, let's do it this way so it's a little better. Let's full screen so you guys can see what's going on. Copy paste 2, 3, 4, 5, 6, 7. Now let's go. Let's go monkey 1, monkey 2, monkey 3, monkey 4, monkey 5, monkey 6. That should be right. No, there are 8. I screwed up. Initial capacity 8. So I need one more. I need monkey 7. This monkey 7. This should be monkey 7. This should be monkey 6. This should be monkey 5. This should be monkey 4. This should be monkey 3. This should be monkey 2. And this should be monkey 1. And now let's go ahead and set up all our conditions operations. So there's that. For monkey 1, return old times old, and the condition is, sorry, the first one should be divisible by 11. This one's divisible by 2. This one's operation is times 7, and if it's divisible by 5, this one is old plus 1. This one's divisible by 17. Does that look right for monkey 3? Yes. And then we're also going to have to go through and initialize all these. Monkey 4 is plus 3 and divided by 19. Man, this is ugly. Monkey 5 is divisible by 7 and old plus 5. And then divisible by 7, is that right? Yes. Monkey 6 is, oh, what is it? Old plus 8 and divisible by 3. And monkey 7 is old plus 2 divisible by 13. So we have to do a couple of other things now. So we have to do, let's take all of these and aggregate them at the bottom actually. 2, 4, 6, 8, 0, 1, 2, 3, 4, 5, 6, 7. Yeah, and now we want monkey list dot add. Let's go ahead and start deleting these. So they can all be at the bottom. So we have a bunch of monkeys and then we mess with them at the bottom. So now if I look for monkey list dot add, wonderful, cool. And so now we also want to add all the things. 0 dot give item. So now we got to go. We got to do this for each of these. 92. 2, 3, 4, 5, 6, 7, 8. Yeah, this is not super extensible, but seems fine. 86, 83, 65, 51, 55, 93. Wonderful. So now monkey1 dot give item 99. 1, 2, 3, 4, 5, 6. 67, 62, oh, nope, 61, 59, 98. Oh man, there must be some better way to do this, but I don't know what it is. Do item 81. I kind of do know what it is, but I don't want to backtrack now. 1, 2, 3, 4, 5, 89, 56, 61, 99, monkey 3 dot, nope. Give item, 97, 2 more. 74. What's up, Owen Codes? How you doing? We're trying to do Advent of Code tonight, which is great, but this one normally it like gives you something that you can pretty easily write a parse function for, but this is not something where you can write a parse function for it like at all. So we're just hard coding some data, which is kind of gross, but it's better than like writing our own custom configuration language. Monkey 5 dot. Nope. Yeah, and I know that here, we'll move this so you can see it a little bit better, but we're just copying in some stuff. This is not rocket surgery. Monkey 6. Its first one is 95. 234. 88. 53. 75. Monkey 7. I see that you have typed something. I will look at it as soon as I finish this line because I do not want to mess up what I'm in the middle of. 2, 3, 4, 5, 6, 7. 50, 77, 98, 85, 94, 56, 89. Just finishing up your full stack bootcamp doing some Django Python framework for the backend. Fair enough. So now for each of these, we have to set what their set true monkey is going to be monkey 3, and this one's monkey 4. So that's 1, 2, 3, 4, 5, 6, 7, 8. This is gross, but it's how we're going to do it. Oh, I believe it. Those coding boot camps are no joke. Did you enjoy it? Do you feel like it's going to be a good fit for you? I know some people do coding boot camps and they love it, and other people do coding boot camps and they just... programming wasn't a fit for them, and they were excited by the prospect, but it's not exactly what they want to do, which is fair. Monkey 4 has 2 and then 3. Monkey 5 has 1 and then 6. Monkey 6 has 0. This code's not going to be testable at all. Monkey 7 has 4 and then 0. We actually don't care about the scanner. 4 into I equals 0. I is less than 20. Plus I. 4 monkey in monkey list. I think this should in order to them. Monkey dot process each item. Cool. And then we now want an int array inspection counts equals new int 8. 4 int I equals 0. I is less than 8 plus I. Oh, come on. Monkey list dot get I is what we're looking for, and we want inspection counts I equals monkey list dot get I dot inspection count. Arrays dot sort inspection counts monkey business score. Here, let's full screen this again so you can see what's going on. Plus, and then we want to get inspection counts 6 times inspection counts 7. That seems more or less correct, so let's give it a shot. It's parsing, it's running, it's thinking, it's doing. Let's look at my CPU usage. CPU usage is pretty high. It's in theory doing something. Here, let's add a little private static final boolean debug equals true. This is a nice little thing you can do to turn on and off a bunch of extra output. We're doing all the stuff. We're in all the places. We're doing all the things. dot out dot println out to do iteration plus I. Java heap space. Okay, cool. So clearly we've got some infinite something. Aha. So, oh, I know what it is. For each thing, we're just looking at the thing. So this is, so I want like items dot. So after we've done this, we can just get rid of all the items. So that's fine. Items dot clear. That should probably help us. There we go. Much better. Let's see whether or not we got the right answer. Okay, that is spooky. So let's go over here. Let's separate out this. Let's create a little no. Let's do this. Let's take all these. Private, static, void. Actually, no, we want this to return a list monkey. Real data. We just put all that in there. Return monkey list. And then we need to take the, where are you? We need to take this. Actually, paste that. We need to take this. Put this at the top. And then we can just call this list from real data, so the name's not dumb. Cool. So now first let's make sure it runs. Okay. Okay, so now we want this same list from real data. Want this same thing. We want this to be list from test data. So this is now actually going to be initial capacity 4 because we know there's only 3 monkeys. 1, 2, 3, and we can delete these other ones. Delete that. Delete everything that references these, and then we're gonna have to mess with these in a little bit. So let's go back through and set up our test data then. We were hoping we didn't have to do that. So this needs items 79 and 98, and everything else for monkey 0 is gone. This needs 54, 65, 75, 74. Everything else for monkey 1 is gone. This needs 79, 60, 97, and everything else is gone for monkey 2. Monkey 3 needs item 74 and nothing else. And for monkey 0, its true monkey is monkey 2. Oh, nope. Oh, nope. Thank goodness for undo. And its false monkey is monkey 3. This one's true monkey is monkey 2, and its false monkey is monkey 0. This one's true monkey is monkey 1, and its false monkey is monkey 3. This one's true monkey is monkey 0, and its false monkey is monkey 1. And then, oh, the conditions are different too. Okay, cool. Let's go. So the operation here is old times 19, and the condition is divisible by 23. This one is old plus 6, and its value is its passes test value percent 19 0. This is old times old, and this is value divided by 13, and this is old plus, 3 and value divided by 17. So that's the same. So let's try the same thing, but rather than doing it with all that stuff, let's do list from test data. And this should be monkey list.size. There we go. And let's do this inspection counts.length. Inspection counts.length minus 2. 2. Second counts.length minus 1. And there should be an n in this length. There we go. Wonderful. Plus, and let's move this down to the next line so we can actually see what's going on. Times this. There we go, that looks better. So if we run this on the test data, we get 10.0605, so that's correct. So that means our configuration is probably set up wrong. So let's check our config. So from real data, monkey 0, old times 5 divisible by 11, old times old divisible by 2, old times 7 divisible by 5, old plus 1 divisible by 17, old plus 3 divisible by 19, old plus 5 divisible by 7, old plus 8 divisible by 3, old plus 2 divisible by 13. So that seems all correct. It's got adds all the monkeys. Okay. 92, 73, 86, 83, 65, 51, 55, 93, 99, 67, 62, 61, 59, 98, 81, 89, 56, 61, 99. Oh, this should... No, it is 99. We're good. 97, 74, 68, 78, 73, 50, 95, 88, 53, 75, 50, 77, 98, 85, 94, 56, 89. And then monkey 3, monkey 4, monkey 6, monkey 7, monkey 1, monkey 5, monkey 2, monkey 5, monkey 2, monkey 3, monkey 1, monkey 6, monkey 0, monkey 7, monkey 4, monkey 0. It's good you learned a lot of stuff, but you could have structured it better. I feel like you just need to pass your last 2 projects to get your diploma. Fair enough. Yeah, so that's... What's... I don't understand. So, list from real data. 121, 103? Is that not what we put the first time? Yeah. Okay, it seems like we've got the right stuff here. Like, all of this seems correct. Monkey 1, monkey 2, monkey 3, 4, 5, 6, 7. All the conditions seem right. The monkey list seems correct. Here, let's get rid of some of the paranoia. Arrow I is less than monkey list dot size plus I. Monkey list dot get I dot process each item. And like, is there any like overflow checking or anything? Like, is that a concern for us? The one that would concern us there is like old times old, right? Should be this one. Let's try debugging it, see what we find. You're right. Thank you very much. Old's 99, 67, 62. These are all fine. Huh. Okay. let's add a print statement to the class monkey. Or I guess like toString. Like void toString. Oh yes, this, sorry. Return this dot, what are we looking for? Items? toString. Let's see. Items plus this dot items dot toString plus \n plus and then we want inspection count plus this dot inspection count. Cool. So then we want to, like, after each one of these, I guess before each one of these, we want to let's make a little private static void print all monkeys list monkey monkey list or int I equals 0, I is less than monkey list dot size plus plus I system.out.println monkey plus I plus monkey list dot get I dot toString. Great. And then we want to print all monkeys for each. Print all monkeys, monkey list. Then we also want to print all monkeys, monkey list. In fact, let's move this one up here, and then let's move this here. Oh no, based upon the way that we should undo that actually. Based upon the way that our other print statement reads, that's going to be better. Let's put this here. What? Why are all these numbers? And we have a negative, which is not good. Yeah, because nothing should be becoming negative. Things divide by 3 or they add none of the inputs. So we have an overflow somewhere. Yeah, 1878. How did all of these turn to 3? Just a bunch of 3s. Okay. Monkey 0 items. $347. Like, is this, what's our, we obviously just have some little, do we need a, like, big integer? Because every monkey gives it to different monkeys, right? No one says themselves. 0 says 3, doesn't say 2, doesn't say 3, doesn't say 4, doesn't say 5, doesn't say 6, doesn't say 7. Okay, so every monkey's giving stuff to other monkeys, so we're cool. How does monkey 3 end up with so many? Here, let's add a debug statement and let's go through. Okay, about to do iteration 0. Play through. And that's what's if old greater than math dot square root dot max value, throw new runtime exception, overflow likely. Here we go. Let's just do this. Stop and rerun. Let's see if we get a runtime exception. Aha! And that's after iteration 8. Great. Crap. Oh no. Oh. Of course we get the one where the overflow is going to happen. Okay. Going to control R. We're gonna go int. I'm gonna turn everything into a long. Okay, replace all. And then we're going to, let's go to where condition is defined. This takes it along, this takes it along. Still needs to be an interface. What's up? How's the bed? Yeah, well, nice.
Watch Rick and Morty and fold laundry.
Okay.
You fall asleep.
Yeah, fair enough. All of these need to have an L inserted. Does it need to be a capital L? Like, is that, why are we mad? No, this requires a long. Requires a long. What else is broken? Does long have a max value? Okay, it does. Go up here. Frontline. Yeah, this is what happens when you replace everything. Is you overwrite some stuff. Okay, everything's fine. There is an error somewhere in here. Get long dot. Oh, actually, this can be I, and this we can just make this an int and be fine. For, yeah, we're going to make this an int as well. Brentlin, thank you very much. Give me any other ones. This should be a long, so we're good. This needs to be an int. This also should be an int. Okay, so now if we run? Yes, of course you can't. 127.56. Let's see if that's right. That is correct. Well, that sucks. You're worried might not ever get the items back. So worried, in fact, that your relief that a monkey's inspection didn't damage an item no longer causes your worry level to be divided by 3. Unfortunately, that relief was keeping your worry levels from reaching ridiculous levels. You'll need to find another way to keep your worry levels manageable. At this rate, you might be putting up with these monkeys for a very long time, possibly 10,000 rounds. With these new rules, you can still figure out monkey business after 10,000 rounds using the same example above. Oh, geez. After 10,000 rounds, the two most active monkeys inspected this many items. Multiplying these together, the level monkey business in this situation is this. Worry levels are no longer divided by 3 after each item is inspected. You'll need to find another way to keep your worry levels manageable. Starting again from the initial state from your process input, what is the level of monkey business after 10,000 rounds? Okay, let's make a... Here we go. Here's what we're going to do. We're going to create an alternative constructor, and this is going to take Boolean part 2, and this was actually just going to call the other constructor operation condition false. Is that right? This, okay. Is that better? Is this better? Yes, it is. Is part 2, actually let's call it worry level decreases, equal, worry level decreases equals, and let's actually call this dot worry level decreases equals worry level decreases. And then we want to go down to here and we want to say if worry level decreases, item equals item divided by 3. And now we can just take this. There we go. So now if we do this, our part 1 should still be intact. This is some ugly code. Oh yeah, so actually this should be true, and we're going to call that with false. There we go. We're probably gonna have to make it like a, nope, I don't want to debug it. Was my answer 127.56? Yes, it was. Okay, cool. So now let's try and copy part 1. Let's get rid of the scanner. Let's stop the debugger. Get rid of the input file because we don't do any of that. And let's move part 2 up to the top because holy crap, do I not want to scroll through all this dumb stuff. Cut. Part 1, part 2. Don't need this. Thank you very much. Also don't need that. So now I want this. Yeah, so now I just want to copy everything inside the try. This, except instead of 20, it's going to be 10,000. We're going to see. Don't care. Cool, so that's part 1, wonderful. And if I do part 2, well, it gave us an answer. Yeah, okay, fair. Oh, and that's because I need to, that's because it's still dividing the worry levels. If I%1000 is 0. I want to do this stuff. We don't want to be printing all the time. There we go. And then the other thing we want to do is we want to list from real data, Boolean, what do we call it? Worry level decreases. Decreases. So now we want to every monkey add this third thing. Yes, right there. 3, 4, 5, 6. I definitely put something in the wrong spot. Cool. And so now in the first part, let's go back to part 1 and get this right. List from real data, true. And so now we want list from real data, false. And we actually want to do the same for list from test data, Boolean array level decreases. Cool. So we take this, and we add a new thing here. 1, 2, man, I wish I had a linter. 4. Cool. And so let's go, first of all, let's just try running it, see what happens. Overflow likely an iteration 0? Really? Already? Oh, well, that's, yeah. Let's get rid of this condition for a moment, and actually an easier way to do this is just, let's run again. Let's see how far in do we get. 128. Dang. Okay, let's take our monkey instead of a deck of longs. Let's make this big integers. Add item as what? Big integer dot value of item for big integer item in items. This will be nice because we can have it take in a big integer if we want. There we go. Cool, there we go. So if worry level decreases, item dot divide big integer dot value of 3. There we go. Do operation needs to return a big integer. I'm just gonna mess with all this stuff right away. Seems like it should be better. We can still put in the longs, but then we're gonna be doing all of this stuff. So control F, it's long do operation, long. Control R, I'll replace this with big integer do operation, big integer, replace all. A second, undo all of these. Now we replace all, should be better. To redo all the conditions. Wow, this is gross. Old dot multiply dot multiply big integer dot value of 5. Basically, want to copy the same thing. Here, let's replace passes test as well. So Boolean passes test long now needs to be Boolean passes test big integer. Replace all. There we go. Now we can go one by one. Big integer, value dot at 11 dot equals big integer dot 0. Right? This? Big integer dot value of 11. Wow, this is just so ugly. Okay. Now we basically want to copy this. Now we can get rid of this because it doesn't equal anymore. Dot multiply old. That's fine. You can copy this. And this is 2. Wonderful. Old dot multiply big integer dot value of 7. You can copy this, but it's with 5. Should have done with the big integers to begin with. You always know it's coming. Dot add big integer dot 1. Fine, we can. No, let's do the value of because it's easier to copy. This 17. This needs to add 3. This needs to divide 19. This needs to add 5. This needs to divide 7. This needs to add 8. This needs to divide 3. This needs to add 2. And this needs to divide, oh crap, 13. Okay. That should be better. Run it. Yes, so now we need to do the old ones. Dot multiply big integer dot value of 19 dot mod big integer dot value of 23 dot equals big integer dot 0. Cool. So now we copy this. We need to add 6. We need to divide 19. We need to multiply by old. Old. We need to divide, oh, nope. 13. We need to add 3. We need to divide 17. Wonderful. Okay, now if we run, oh, we left the print statement on for every single time. Oh, iteration 167, 173. Let me stop. This is taking too long. Let's go up to here. Where's part 2? Part 2. If this divides 100. Because we only got to, I don't know, a couple hundred. 200. There we go. We're already much faster. 300. Oh, geez, these big integers. It's going to take a minute. Yeah, look at how big these numbers are. Let's make sure, let's keep an eye on our RAM usage. It's currently at 17 gigs, but we're doing okay. Although I guess I also don't have any view into like the virtual machine to know. There's probably some math we could do on all. There's probably some math we could do to figure this out. If we like drew it as a chain, we would know. Because we basically only care about some moduli, right? Which if we look at the first, because yeah, we're still stuck, right? Again, holy crap. Okay, here. Let's not print all the monkeys, and let's just do the thing. Let's stop, and let's rerun, and see if that gets us any faster. So we just saved ourselves, I don't know, 300 megabytes or something. Okay, and while we're doing this, let's get out a notepad. I'm going to move this back over here. But I'll let you guys know if the RAM gets out of hand. Yeah, we're stuck at like iteration 200. In fact, let's find out which iteration we're actually stuck at. Now that we're just printing out the line, we should be fine. It's starting to get real slow. Yeah, there it is. So really, if we look at the things here, the only things we care about are divisibility by 23, by 19, by 13, and by 17. So really, can't we just multiply all of these? So if we take a calculator and we just take 23 times 19 times 13 times 17. I hit divide somewhere in there. Crap. 23 times 19 times 13 times 17. Can't we just do everything modulus this? Yeah, so then for our input, we can do the same, but the things that we want to divide by are instead 11, 2, 5, 17, 19, 7, 3, 13. Which are all prime numbers I'm now seeing. So 11 times 2 times 5 times 17. Nope, 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 nope. Clear. 11 times 2 times 5 times 17. Escape, escape, escape. Why won't it let me? Oh, because I hit numlock. 11 times 2 times 5 times 17 times 19 times 7 times 3 times 13. Okay, so let's take that. And let's take the items. And anytime a monkey gets an item, I think that's a fine time to do that. So after we do this, then we can say, this is only going to work for our, we want to make it work for test data and for real data. So we want to make this another input here. Let's go ahead and move these down so we can see what's going on. So we want another, and this is fine for now. We basically want another thing here, which is let's make it a long modulus. Long modulus, because all we care about is what we're doing relative to this modulus. So we actually want to call this operation condition worry level decreases and the modulus is 1. And so if we have the modulus whatever, and then we want item.divide whatever, item equals item.mod big integer dot value of. In fact, well, we can just make the modulus a big integer. This dot modulus equals big integer dot value of modulus. Fine. And then we can just say item equals item.mod modulus, which is fine. That shouldn't affect the condition at all because all the conditions are just divisibility, so we'll be okay. So now we just need to go to the monkeys, and I actually want to delete these default constructors so that it'll just error for me. And then I can go to the place where it's mad, and for list from real data, fine. Yeah, we also want a long modulus. Oh no, because this is real data. Real data and fake data we already have separate. So So we can just say long modulus equals, and on the real data it's 9699690. And then we want to go like worry level decreases, modulus. We basically want to do this every time we see worry level decreases. Worry level decreases, worry level decreases, decreases, and then it should get mad in the test data, and we'll just set a different modulus there. God damn, this is ugly code. Long modulus equals, and in this other one we said that the only values were 23, 19, 13, 17. We multiply those. 23 times 19 times 13 times 17. Does that seem right? Let's clear everything. Clear, clear, clear. Can I clear the history? Delete the history. 23 times 19 times 13 times 17. 96,577. And now we just want the same. Oh. There we go. There we go. There we go. Okay. So let's stop and rerun now. We only got to 273 on our other iteration. Now that we run the modulus, this should run very fast. Oh yeah. So here's our answer, supposedly. Let's give it a shot and see if it works, and if it doesn't, we'll see whether or not we get the right answer from the test data. That is the right answer. Cool. So let's go ahead and see how we did. Leaderboard, personal stats, 3,000th, 2,900th. That's unsurprising. We ran into like a pretty... What was the issue? We were having an overflow error, so like... Yeah, Doe had an issue. Let's take a look at our leaderboards, and then we're going to have to do a lot of cleanup here. Okay, nobody's tried it from work, and nobody has... Yeah, of course nobody's tried it from the other one. Okay, fair enough. Not our greatest showing. But let's go back through, and first let's copy this, and then wow, I am ready to be done for the day. Okay, let's go back to the top and see if we can get this formatting right. Blah, blah, blah. How worried you are about each item. Starts on how. This. Each monkey has several attributes. Starting items, operation, test. I think that that's correct. And then if we go here, yeah, exactly. Perfect. So starting items, worry level, operation, an operation like new equals 1 times 5 means blah, blah, blah. Of course, figured that out. Test, show stuff. If true, if false. Oh, no. If the test is true or false, divided by 3. On a single monkey's turn, and it goes round, and then we need monkey 0, monkey 1, etc. Here, here, there we go. And it doesn't, that actually doesn't matter, like the order that the monkeys do things. Example above, here's what happens. Long list of monkeys doing stuff. Great, after round 1, this. And then this continues for a while. After round 20. This needs to be moved down a line. The 2 most active monkeys. Monkeys goes outside. Count the total number of times each monkey inspects items over 20 rounds. This line needs to be bolded. This line needs to be bolded. This is an example, level of monkey business is this. Figure out, we're looking for what is the level. Puzzle answer was this, part 2. Wonderful, you're worried. No longer cause it to be this. Find another way. Very long time. Possibly 10,000 rounds. No rules. Round 1. 10,000 rounds. The level of monkey business is now this. Where's monkey business? What is the level of monkey business after 10,000 rounds? Your answer was this. Both parts are complete. Wonderful. Okay, let's go back through and let's consider reordering the data. So instead of this, let's look at structure. We have monkey operation condition. That's fine. I want to print all monkeys to be above the real data. There we go. Print all monkeys. And then I actually want these classes. I guess they do go at the bottom. I'm just the fact that all of this like hard-coded data in here is kind of gross, but that's okay. All right, so let's go through and count. Do 20 rounds. If debug. If debug. Great. Find top 2 scores to compute final score. Okay. Do 10,000 rounds. This is fine. If debug and this, not the other way around. And then similarly here, if debug, and we'll do it right here. Find busiest 2 monkeys to compute final score. And then I want to include a couple of notes in the monkey class. So let's include this on the module listing itself. Can divide all, can modulo all numbers by this value, since all we're doing is, let's move the comments to somewhere less dumb, like here. Applying and heading, which are safe to do. Compute this by multiplying all monkeys condition values together. Cool. All right, so let me explain what's going on here. So we constructed. So first, what we do is we get the data either from the real data or from the test data. We didn't end up using this at all. Data is in Java class itself. Parsing is too hard today. So what happens is first we construct our set of monkeys, and the way that we construct our set of monkeys is each monkey has a couple of things that are relevant to it. So if we look at the monkey class, we can figure that out. So first of all, it has an operation and a condition. The operation is what you do to the item worry level every time the monkey holds that item. And the condition is how we check which monkey to pass it to. So if we check out operation, you can see there's just something which is computed for each monkey where it takes in a big integer and spits out a big integer. Although it doesn't need to be a big integer, actually. These could have stayed longs if I'd figured out the modulus thing fast enough. And then the condition, just given a big integer value, returns a Boolean. And so these are all hard-coded. If we go to back where the real data is set up, you can see that we're hard-coding all of these values. So the other thing we do is we add all these monkeys to a list so we can keep track of them and go monkey 0 to monkey 7 in order. And then we give each monkey its items in order. Great. And then we set, if its condition is true, does it go to monkey 3, or if it's false, it goes to monkey 4, etc. And that's all hard-coded based on the input data, which you can see here. So this is where we got all that information. So once we have our set of monkeys set up, what do we have to do? So in part 1, we have to run 20 rounds. And then we have a little debug statement here so we can see what's going on as it goes through. And basically we just go through the list of monkeys and we process each item in the monkey. So process each item, grabs each item that the monkey is currently holding, runs its operation to update its worry level. In part 1, there's a thing where your worry level divides by 3. So it's constantly like a going down, which is not a big deal. And then we run it against the modulus so that the value stays small, but that's not really necessary in the first part. And then we check the condition, and if it's true, then we give it to the true monkey. If it's false, we give it to the false monkey. We count the number of items that we've inspected, and then we clear all the items on ourself, which we do after looking at all of the items. And that's because nothing's going to get passed back to us. We do all the work up front. So after we do all of that, we take the inspection counts from each of the monkeys. We grab them all, put them in a thing, we sort them, and we grab the highest 2 in order to multiply. So for part 2, the only gimmick here is that we need to do it 10,000 times. And the only difference there is that, one, we ended up with overflows. So the way we solved that was by using big integers, but then the values just get too large. So we could only, in the course of about 5 minutes of running, get like 250 of the 10,000 things. And it was going to get worse because the numbers just keep getting bigger, right? So that's where we figured out that the modular arithmetic was going to be useful. So you can see, if we look at our real data, that the modulus we can use is 9,699,690, and that's what we get by just taking the if it's divisible by 11, it goes to this monkey or that monkey. Well, if we just multiply all these and then modulus by that number, we haven't affected what any of the conditions are, so it should still be fine. And we're blurry. Come on. Oh, I don't like that we're still blurry here. Let's turn our thing on. Nope, we're just still blurry. Am I blurry now? What about now? It won't. Oh man. Let me open up the Logitech software. Logitech camera settings. And just opening that program solves the issue. Wonderful. Didn't even have to do anything with it. Okay, so now that we have that modulus, we can run all the stuff, and then it runs really fast because then all the numbers stay small, so it's fine. Using big integer was kind of a mistake, but you win some, you lose some, and the fact that we spent all that time hard coding that is why we got such a bad result today. Anyways, it was a long one today. I was happier that it was a little bit harder, a little bit annoying that so much of our time was taken up figuring out the input and stuff, but still happy with what we got. All right, I'll see you guys in the next one.